So here is a bit of a summary of the work that I've been doing, not full time, but over a period starting October 24, when I knew very little about how to set up an aftermarket engine management system. Still probably don't know that much, but from scratch this was something that I've never really got involved in before. I can show you. So up in there is the Motorsport Electronics ME360 engine management system, which still isn't fully mounted in place, and yes, to be honest, there's probably a little bit more tidying needed. It is on its bracket, but the screws aren't done up, and it's connected through using the main plug that is from the engine management system that came with the Jaguar. I can't get you a better view of it than this at the moment, but yeah, this is actually, if you like, the inside of the Jaguar engine management system, which then plugs through the bulkhead and comes out in the engine bay, where it mates up with the original engine harness. Now again, not quite as tidy as it will be, because as I may have mentioned, all of that's going to have to come out, because I've got no reverse gear at the minute, and that happened because I foolishly undid something on the side of the gearbox, which was not the oil filling plug, but something to do with the selecting arms. So yeah, that's something of a self-inflicted injury, but it will reach a higher degree of tidiness quite soon, I think. But anyway, that's all an aside. So this is the Gilbern Invader in its, well, still fairly rough state, I suppose, but not too bad. Now, you've seen me do lots of fabrication, brackets, fiberglass, I don't know, fitting windscreens, fitting the engine, and all that. But all of that is kind of, I wouldn't say finished, something which I've never really done before. I mean, I know all the principles, and I've read up a lot about it, and I know what's going on, but at the same time, I've never actually done it. I've never actually put in an aftermarket ECU and set it up. These are the wires from the drive-by-wire throttle pedal, and this pedal, in actual fact, is from an Audi A6. So now I'm trying to decode my electronic throttle pedal, and of course there's multicoloured wires coming out of the plug body, and I've just had to extend them, obviously with wrong colours, if you like, but at least I've written down what they are. So I'm now going to attempt to stick a meter on those and see what happens. So we seem to have, looks like 1.5 mega ohms. That's quite high. Now if I press the pedal with a pokey stick thing, I need a pokey stick thing. Alright, so does it change? Not at all. I'm going to stop work on this pedal until I've spoken to Motorsport Electronics again. Traditional potentiometer or possibly Hall effect. But by the look of, I've prized the lid off, and then we have, can you see in there, a load of wiggly circuity things, and there's no sign of a magnet. So I think, from what I've read by Heller, this is neither Hall effect nor potentiometer. I've had to move away from purely using the original wiring on the engine and the main reason for that is this thing, which is the original 1999 Jaguar drive-by-wire throttle motor assembly, because the interface to it we couldn't possibly retro understand, or what's the word, retrofit? No, we couldn't reverse engineer it. That's a much better word to use. The new one is just this little bit on the end. Let's see a lovely... Hello Jessica. The new one is just this little bit here on the end, with a lovely conversion piece which AJ30 Engineering in Benfleet made for me. But this thing here has a plug which has got only 6 wires. So 6 wires as opposed to 22. And thanks to well, Superfast Matt leading me to D-stage, Superfast Matt leading me to D-stage, can't say it, D-stage in Poland, who used one of these. This is from a Fiat Punto, and it's actually a Bosch part, and I've tested it, and it really is a resistive sensor, so probably a lot easier to use. And the key part, once again, is the shaft is made of metal, which means it can be welded, bent, whatever, in a way that a plastic one wouldn't be able to. So I was just about going on to a remote session with Motorsport Electronics to possibly get the first bits of activity out of the engine. Of course, first thing they said to me is, have I got a timing light? Well, yes, I have got a timing light. Just here. One slight problem with it though. It's designed to go clip over an HT lead. Do you see any HT leads on this engine? No. Spark plug leads? No. Because I've got coil on plug ignition, haven't I? So I suppose, anyway, that if I take the coil off plug number 1, maybe I can kind of put an extension lead in place. I shall have to pinch a spark plug lead from another car, I think. But as well as the need for a timing light, I also need to know where top dead centre is. Can I see the timing marks on the front pulley? No, I can't. I'm going to have to take the spark plug out, I think, and stick a long screwdriver down the whole socket onto the crank pulley, so I can actually turn the engine over by hand. I've made a little mark. So as you can hopefully see, I've marked on my screwdriver the exact position it intersects or touches the spark plug hole just there. Spark plug goes in here, and not high tension, just low tension wires go in here. So I've borrowed a spark plug lead out of the a yellow car. Here it is. And I reckon there's a possibility that I can fix this onto that, and then this onto that, but in the car, in the engine. But now I've got a spark plug lead that I can use, unlike on a traditional engine which relies on its timing marks on the crank front pulley or what have you. The crank sensor ain't necessarily at top dead centre. So if you imagine top dead centre is where my fingers meet in the overall cycle, if that's top dead centre there, the crank sensor could be over here, let's say, or over here. So there's very likely to be an offset between where the crank sensor is and where top dead centre is. Where my thought process, and it has taken me a little while, reached was to use a screwdriver down the bore. Now you saw me do this, and I made a little mark with this tape that lines up with a spark plug hole, and basically as the piston comes up, obviously it rises up, and then as you go past top dead centre, it goes back down again. Up and then down, up and then down. So if I mark the crank when it reaches the tape on one side of top dead centre, and then up and down and mark it again when it's on the other side, we'll have two marks on the crank pulley, and the point, this is the important part, the point exactly in between is top dead centre itself. Okay, this is my screwdriver. I've taken the spark plug out, of course, and I put it down the spark plug hole, and in fact it is, I'll take you and show you. You can see that the bottom of the tape intersects with the side of the spark plug hole just there perfectly, because that's, I put the tape on particularly to achieve that. Now if I can do this and hold you at the same time, if I turn the crank pulley round, now just imagine I've marked the crank pulley at this point, by the way, which I have. So I'm going to wind, so we are going upwards and going downwards again. Well, okay, that probably didn't film amazingly well, but suffice to say, by doing this I've actually managed to put two marks on the crank. So we have one mark from where the tape lines up, we have another mark from where the tape lines up, and I've split the difference and chosen this point, obviously when it's there, is where top dead centre is. It may not be quite as accurate as using a dial gauge, but considering we're mainly looking for an offset to get the ignition timing started, not finished but started, I think that's pretty good actually. Right, the plug's back in. Let's take that off for a second. Now this plug lead is actually a little bit too big to go in the hole, so I hope that's not going to be a massive problem. Well, it's in the hole now. Okay, so here we have the plug lead, which is not normally there. We'll put the low voltage connection onto the coil on plug device, as I keep calling it, and we'll see if the timing light works at all. Okay, so I'm going to switch the light off so I can see more clearly and check the strobe on here. I'd say that was slightly further advanced than it needs to be. I'll change the figure. So today, I'm hoping maybe to go with a first fire up. We have everything connected, I think, and the noise you can hear whining there is the electronic throttle body, which works, electronic throttle drive-by-wire, which works. So it's kind of annoying actually, but maybe inaudible if the engine were actually running. Other things I've connected recently include the map sensor and inlet air temperature, so we may be ready to go. Right, nothing happening. then. Yeah, that's doing something.
Okay, I'll continue to give it a bit more then.
It was starting to... Well there, that is such a big step forward compared to what we had before. It's quite amazing. All is not quite well, but nevertheless. So I'm going to run this again, keeping an eye on the diagnostic screen. Now here's another thing. Obviously it's not running properly, and it's very tempting to assume it's something to do with the ignition timing or something, but I thought, why not check the fuel injectors? So I've switched the ignition off, and in here you can see the actual fuel injectors, or what one of. There you go, all three of them there. And if I turn the key, you can see them squirting fuel. I don't know whether this is going to work on camera. Right, yes, squirting fuel. Let's start with, oh no, left to right, okay. Yep, so those three are working. Seeing if you can see what I can see over here. Now this one appears not to be squirting. Alright, so I've come up with this thing. Now this is an ordinary plant sprayer pump up thing. I have got, this is indeed WD-40, bought by a 5 litre bottle I think, and I've pumped it up. I've effectively inflated the pipe and therefore the injector with WD-40 by releasing the trigger, and now if I press the, or connect the little terminal here, as you saw, there is indeed, well, WD-40 coming out. Now it's not a particularly impressive spray, although I suppose the pressure isn't as high and the WD-40 isn't as thin as petrol, but let's see, try that again. Yeah, okay, so as I say, it's not a particularly impressive spray, but it isn't actually fuel. Now I'm kind of tempted to attempt this with fuel, but what is sure is that it is actually working. So whatever the problem is with this injector, it isn't that the injector is blocked. So I did check the wiring harness for the injector rail. All 6 injectors, well, they all clicked away according to the appropriate pin on the big plug at the back. So it would appear that whatever the wiring problem may be, I'll just show you the plug, whatever the problem may be, it's not in that mini harness. So that's the end of that mini harness coming back from the fuel rail. That's all nicely cleaned up in there. So the cylinder that I couldn't see squirting was this one, and I had to go and check my firing order, which in fact says that this is cylinder 1, so that one's number 4. Now, according to the wiring, number 4, can you see this? Number 4 goes to pin 32, and this is on that great big plug, not the ECU plug, the great big plug, and that's the first next place I'm going to check. Right, so the ECU end of the wire from the fuel injector is actually grounded, or it becomes grounded. The ECU does the grounding. So in other words, the live end should be there already. So by finding pin, what did I say it was, 32, and with this piece of wire I can send that to earth, and we will know that the connection is going through from the big plug in here through to the fuel injector. Now luckily I have actually labelled the back of the wires here. Well, predictably perhaps we've got a wire off, and that's why the injector's not working. Yesterday I did a fair amount of work. I actually lost the connection to the injector on cylinder number 4, which I've now put back in place, and I checked the other ones as well. I didn't check the other ones. I checked all the column plug device connections to go into the right cylinders. The connections to the fuel injectors are actually quite hard to check through, although I did check number 4 because obviously it wasn't working previously. So what can we do is only test it. I mean, it was correct before, at least I certainly thought it was at the time. So that's the only thing to do, is test it again. And I've even just spent a moment tying up the lambda sensor, sorry, wideband sensor on the floor, under the floor. Remembered something. I think I switched the ignition off. Yes, I did. That wants me to power cycle. Right. Okay, ignition is back on. Let's see what happens. Better. So let's see what happens now. My hair. Anyway, this could be quite momentous. Let's see. what a lovely day. Now, I've been working on the engine, the AJ30, which came from an S-type Jaguar originally, for quite a while. And even as long ago as New Year, you may have seen me drive around our little cul-de-sac up there, and you know, seemingly all going fairly well, which it has been, but it's never been in a state where I'd be happy to drive it up the road. But there has been progress aside from the exhaust, all that stuff you might have seen, getting some reasonable ground clearance. The engine was just not quite smooth enough to be comfortable, let's say. But in recent days, really, and I'm speaking now in April, there has been progress with the management system, and also my understanding of the Motorsport Electronics MED360 software, which manages the ME360 ECU, which is the ECU I had to put in here because the Jaguar one was unusable due to the fact it required the original instruments and so on to actually work. So anyway, there has been progress, and I'd like to take you through some of the, let's say, elements of that progress, recent progress that is. You will have seen earlier in this summary episode some of my early steps where it coughed and spluttered and probably did a bit of popping and banging and so on. But I think we might now be at a point where realistic running can be contemplated. I've got a surprisingly long wire running, I don't know how far it is, getting on for 20 feet from the laptop here into the ME360. It's running on USB out of the computer, bit of an extension cord, and right at the end it goes through what's called an FDTI adapter cable, which changes USB to proper 9-pin serial, more traditional type of connection in many ways. But anyway, it works, and as you can see, we are online. So what are the particular parts of significance in relation to the recent progress? So right here we are on the start screen. Maybe I can zoom you in a little bit further. Alright, so this is the start screen. As I said, you can see that the laptop is connected to the engine management because it's gone green here. But one of the things which was not completely correct until recently was this table here, the injection driver within the start tab. And it's to do with the size of the injectors. Now, I won't change it because it's such a struggle, or it has been such a struggle, but you can put your cc of millilitres or cc's per minute, and as you can see that says 190, and what it says here below it is fuel pressure, the reference pressure, the actual pressure which is set in the pressure regulator, and the reference pressure which is for the injector when the figure in there is whatever it is. Now that, my friends, was wrong. This figure, which is currently showing 190, was showing 300. Now, albeit the reference pressure was 350, so it was rating at a higher pressure. So in other words, when the fuel rail pressure was 350, the capability of the injector was deemed to be 300 millilitres per minute. I'm not sure it was minute or per hour. Minute. Now, when I looked up the S-type Jaguar injectors, I discovered that the actual figure is 190 at a reference pressure of 300. Now, of course, if you did turn the pressure up to 350, like as not, this figure would actually go up, but I don't think it's going to go all the way to 300. So this has had the effect of made richer, more fuel is going in as a result of the computer in the car expecting that the maximum flow rate from each injector is only 190 as opposed to 300. Now that of course assumes that the injectors are experiencing a 100% duty cycle. In other words, they're fully open, and the computer of course opens and shuts them very quickly. So if it's expecting that the injectors are capable of running 300, whereas in actual fact they're only capable of 190, everything is going to be offset to be leaner than it should be. And that explains why I was getting lambda readings of, well, I saw 20 mentioned when it was, sorry, when I say lambda I mean air-fuel ratio, AFR figures in the range of 20, whereas the approved, if you like, standard figure for petrol is 14.7. And what a higher figure means is that there's much more air than fuel, and in other words, if it's at 20 versus 14.7, it means that it's running much too lean. So by changing this figure here from 300 down to 190, the whole fuel table has been enriched. The next thing I discovered, it was the engine wouldn't really rev, and I thought, what the heck's going on? Why is that? The engine wouldn't rev, it was spluttering when if you get to about 4,500 RPM. And I thought, what's it running too lean again? And then I thought, I know, there's a rev limiter set, isn't there? Now that is sensible when you're running a brand new engine and you don't really know at all what's going on. But the rev limit was actually set to around 4,500 RPM. Now what we have here is the rev limit table, which is showing coolant temperature and maximum RPM on the vertical scale. So what that shows is, at the moment, and I've fiddled this figure, first it's limited when it's stone cold, and then when it's up to running temperature I've limited it to around 6,000, which is probably again a little bit conservative, but this engine is not brand new, it's well run in, that's for sure. So again, this has had a major effect. So those are the two major things, and it's now reached, the car has now reached a stage of what I would call sensibility. So we're not quite out of the woods, as you saw with my struggles in getting to idle. What you might have also noticed is the rev limiter cutting in when I first started the engine, which of course is the coolant sensitivity, which I just mentioned. Anyway, it's now idling, so now what I can show you is the fueling. Now what you can see here is the fuel. That's showing how much fuel is going in, and the higher or the lower down here, the more fuel basically, and RPM on the right, and the ignition is over here, and that's showing ignition advance. Now you'll see up here a figure of 14.5-ish, which is pretty close to that ideal figure of 14.7. Now the other slight revelation that I had is if I select one of these cells, let's say that one, I can change the fueling. So that's currently, now it's measured in AFR, which is, I don't mean AFR, do I? It's currently measured in VE, which is volumetric efficiency. Now I'm not going to go into that partly because I don't really fully understand it. But anyway, suffice to say, if I increase the number, there's more fuel going in, and if I decrease it, there's less fuel going in. And that happens if you press the keyboard. You've got Q and W. Q for less, W for more. It's just the left-hand corner of the alphanumeric keyboard. And so if I take this number here, as you can see, it's going up 31, 32, 33, and back down again, 31, 2, 31, 30. You will also see, if I actually select the cell where the engine appears to be running at the minute, which is here, and it is running possibly too rich, so I'm going to take some fuel out. We have live tuning going on here. And hopefully you can see the lambda figure changing. It's about 14.7, which is the ideal figure. So in actual fact, maybe it's even running slightly smoother than it was just a minute ago, which is nice. So I'm going to try and kind of smooth out the numbers. If I go into this, if I press the 3D button here, we get this map, which gives you a visual representation of how lumpy the fuel map is. Is quite good as a visual reckoner, as it were. So again, I'm going to take some fuel out to make it run leaner. It's still 13. That's a bit low, so I'm still taking some out. Is relatively stable now. So there we are. Now this method of adjusting the fueling using the keyboard, I was completely unaware of until I watched one of Motorsport Electronics YouTube videos. So there's a lot to this, and not all of it is kind of obvious. But these are the points which mean that I was able to improve the running. So yeah, 14.7 is fairly ideal. If I go and sit in the car and rev the pedal, you should see my little target moving around, and you should also see, and I'll come back and watch you later on, what the AFR actually does. Now I should say, don't mean AFR, do I? I mean lambda figure. What that actually is, sorry, it is AFR, I was right the first time. See what the AFR really is while it's running, but I will point out, of course, there's effectively zero load on the engine, so it's limited on how relevant, if you like, this is, and that the load will determine where we are on this vertical scale. At the moment it's right near the bottom. Let's have a look at that and take the 3D version again after I've fiddled it. Yeah, so that is looking relatively smooth. I don't know whether that needs to be enriched over there. Maybe it does, but we'll see. I shall do a bit of revving and we'll see what happens. You'll be able to hear from the sound what's actually occurring, and you'll be able to see RPM, which is currently 600, AFR, which is over here, and the ignition, I'm leaving that as it is for the moment. Let's have a look. And so there we have it. The engine is free running. It's not coughing and spluttering like it was before. Idling fairly well. It's not perfect, of course, but could be good enough to take it out. If you got as far as this, thanks very much for watching, and in case you haven't already, please do consider subscribing. That would be really encouraging for me. So catch you on the next one.